Welcome back to our ongoing deep dive into the world of mathematics.
Always exciting to be back.
In this one, we're tackling a constant that has fascinated mathematicians for millennia, pi.
Yeah.
You probably know it as 3.14159 and so on. But
Right.
we've got some fascinating sources here
Okay.
from the Wikipedia entries on both pi itself
Uh-huh.
and the history of its approximations to articles that delve into its cultural impact
Wow.
and modern applications.
Cool.
So
Right.
get ready to uncover why pi has held such enduring fascination,
Okay.
how we've gotten closer and closer to its true value over time, and why you should care about a number that seems to pop up everywhere.
It's everywhere.
You know, when I think about ancient civilizations,
Yeah.
I imagine them grappling with more immediate concerns,
Yeah.
like, building shelters and finding food.
Right. Right.
But it turns out
Yeah.
they were already thinking about pi.
That's amazing.
Our sources indicate that civilizations as far back as the Egyptians
Uh-huh.
and Babylonians
Wow.
had a pretty good grasp of it.
It's incredible.
It's fascinating to consider that even back then they recognized the importance of pi for practical calculations,
Yeah.
especially in architecture and astronomy.
Absolutely.
Take the Egyptians, for example.
Okay.
They estimated pi to be about 3.16,
Okay.
a value they seemingly derived from the dimensions of the Great Pyramid of Giza.
Oh, wow.
Now, whether they intentionally designed the pyramid to reflect pi,
Mm.
or if it's just a coincidence is still debated.
Right. See.
But either way, that's a pretty impressive level of geometric understanding for their time,
For sure.
wouldn't you say?
Absolutely.
And the Babylonians weren't far behind.
Okay.
Around 1900 to 1680 BC,
Right.
they were using a value of 3.125 for pi,
Okay.
which again points to a sophisticated understanding of geometric principles
Yeah.
for their era.
It really does.
It really sets the stage for the ingenuity that was to come.
Yeah.
Speaking of which, can we talk about Archimedes?
Oh, yeah, sure.
This guy was a true pioneer.
Uh-huh.
Working around 250 BC, he devised a method for approximating pi.
Okay.
Using polygons, of all things,
Polygons.
Archimedes' method was truly groundbreaking.
It was really ahead of its time.
By inscribing and circumscribing polygons around a circle
Mm-hmm.
and continually increasing their number of sides,
Yeah.
he essentially trapped pi between two converging values.
Right.
His method was so ingenious
It really was.
that it remained the dominant way to calculate pi for over 1,000 years.
Wow.
Wait, so you're saying this guy,
Yeah.
using nothing but his brain and some geometric shapes,
Pretty much.
managed to lay the foundation for how we understood pi
Uh-huh.
for centuries?
That's right.
That's incredible.
Yeah.
What kind of accuracy did he achieve with this method?
Well, he was able to determine that pi falls between 223 over 71
Okay.
and 22 over 7,
All right.
which is remarkably accurate considering the tools he had at his disposal.
Wow.
It really makes you appreciate the power of human intellect to unravel such fundamental mathematical truths.
It's mind-blowing, right?
Yeah, it is.
I mean, no calculators, no computers,
Right?
just pure logic and geometric reasoning.
Exactly.
But as we move through history,
Yeah,
things started to change, didn't they?
they did.
How did the way we calculate pi
Mm-hmm.
evolve from these polygon-based estimations?
Well, that's where the story takes a fascinating turn.
Okay.
We begin to see the emergence of a completely new approach in the 17th century,
Uh-huh.
the development of infinite series,
Okay.
which really revolutionized how we approach pi.
Okay, I have to admit,
Yeah.
whenever I hear infinite series,
Right.
my brain starts to go a bit fuzzy.
I understand.
But that's why we're here, right?
Exactly.
To unpack these complex ideas.
That's the goal.
So let's dive into how infinite series changed the game for calculating pi.
All right, let's do it.
So we've established that ancient civilizations had a surprisingly decent grasp of pi,
Yeah,
especially considering the tools they had available.
absolutely.
But you mentioned infinite series becoming a game changer.
Right.
What made this approach so revolutionary?
Well, it marked a shift from geometrical approximations to a more analytical way of representing pi.
Okay.
Instead of relying on shapes and measurements,
Yeah.
mathematicians could now express pi as an endless sum of increasingly smaller terms.
Okay, that sounds intriguing, but I have to admit,
Yeah,
the concept of infinite series still seems a bit daunting.
I understand.
Can you give me an example of what one of these series looks like
Of course.
and how it connects to pi?
One of the earliest and most elegant examples
Okay.
is the Gregory-Leibniz series, discovered independently by James Gregory
Uh-huh.
and Gottfried Wilhelm Leibniz in the 17th century.
All right.
It states that pi can be calculated as 4 times the sum of
Okay.
1 minus 13 plus 15 minus 17 and so on.
Let me see if I'm following this.
Yeah.
So we start with 1,
Yes.
subtract 13,
Right.
add 15, subtract 17, and keep alternating like that forever.
Exactly.
That's how we get to pi.
That's how it works.
The pattern is simple.
Yes, it is.
But the magic lies in the fact that as you add more and more terms,
Right.
the result slowly but surely approaches the actual value of pi.
That's the beauty of it.
It's fascinating how something as simple as adding and subtracting fractions
Yeah,
can lead us to something as profound as pi.
I agree.
But you said it converges slowly, right?
Yes.
So how practical was this method for actually calculating pi?
You're right.
Okay.
The Gregory Leibniz series, while beautiful in its simplicity,
Yeah.
is not the most efficient for getting a highly accurate value of pi.
Okay.
It takes a huge number of terms to get even a few decimal places, right?
So it's more of a theoretical breakthrough than a practical tool.
In a way, yes.
Okay.
But remember, every step forward in understanding pi,
Right.
whether theoretical or practical,
Yeah.
opened new doors.
I was about to say,
Yeah.
someone must have figured out a way to speed things up.
Indeed, even giants like Isaac Newton,
Newton?
yes,
Wow.
took an interest in the problem.
The guy who figured out gravity
That's right.
was also messing around with pi calculations.
He was a brilliant mind who explored many areas of science and math.
That's amazing.
In 1684, he used his newly developed calculus to find a way to accelerate the convergence of the Gregory Leibniz series.
Hold on, Newton calculus
Uh-huh.
provided a significant boost to the accuracy and speed of pi calculations?
It did indeed.
So from polygons to infinite series and then Newton's calculus-powered speed boost,
Yeah.
it sounds like the pursuit of pi was really driving innovation
Absolutely.
in mathematics as a whole.
It was a driving force.
And the story continues with even more ingenious developments.
It does.
In 1706, John Machin, building on the work of others,
Yes.
devised a formula
Okay.
involving the arctangent function
Arctangent.
that allowed him to calculate pi to 100 decimal places, a new record at the time.
That was a big leap forward.
Arctangent.
Yes.
Now we're getting into some serious trigonometry here.
Bit more advanced.
Was this a completely different approach from infinite series?
It cleverly combined trigonometry with the power of infinite series.
Okay.
Machin's formula and others like it
Yeah.
became the favored method for breaking pi calculation records for many years.
So we've gone from polygons to infinite series,
Right.
turbocharged by Newton,
Yes.
and then refined using trigonometry.
That's a great way to put it.
It's like an epic relay race,
I like that analogy.
where each mathematician passes the baton, pushing the limits further with each leg.
Yeah, a collaborative effort spanning centuries.
And this pursuit of pi's decimal representation wasn't just about breaking records.
No, it wasn't.
It also led to some profound discoveries about the nature of pi itself,
Exactly.
beyond just its numerical value.
That's right.
Okay, now you've piqued my curiosity.
Good.
We touched on the terms irrational and transcendental earlier.
Yes, we did.
I'm ready to dive into those mind-blowing aspects of pi.
Let's do it.
All right, let's talk about these terms irrational and transcendental in the context of pi. I have to admit, they sound a bit intimidating. What do they really mean, and why are they such a big deal?
They highlight how pi is fundamentally different from the everyday numbers we're used to.
Okay.
Take a simple fraction like 14.
Uh-huh.
You can easily write it as a decimal 0.25.
Right.
That's a rational number.
Okay.
Because it's a ratio of two whole numbers.
Makes sense.
But pi can't be expressed as any neat fraction like that. It's, as we call it, irrational.
So no matter how many decimal places we calculate,
Yeah.
there's no repeating pattern, no fraction that perfectly captures pi.
Exactly. It's an endless, non-repeating decimal. And this irrationality of pi was first proven by Johann Lambert back in 1768, marking a significant step in our understanding of this unique constant. But then things get even wilder when we consider that pi is also transcendental.
Okay, now transcendental definitely sounds like we're entering the realm of mystical mathematics here. What does that even mean for a number?
It means that pi cannot be a root of any polynomial equation with integer coefficients. To put it another way, you can't create an equation no matter how complex, using only whole numbers and basic operations like addition, subtraction, multiplication, and powers that would have pi as a solution.
So pi is like a mathematical rebel, breaking free from the confines of traditional algebraic equations.
You could say that. It exists on its own unique plane-defined simple representation, and the proof of pi's transcendence came in 1882 thanks to the work of Ferdinand von Lindemann, finally putting to rest a long-standing mathematical debate.
It's incredible how mathematicians, over centuries, pieced together this understanding of pi, uncovering its true nature bit by bit. But we can't talk about pi's history without mentioning Srinivasa Ramanujan, right?
Ah, yes, Ramanujan. His work with pi in the early 20th century is simply astonishing. This self-taught Indian mathematician seemed to have an almost intuitive grasp of pi, producing incredibly efficient formulas for calculating it.
I've read that his formulas were not only incredibly effective, but also strikingly beautiful, almost like works of art in themselves.
Precisely. His insights were profound and truly groundbreaking. He seemed to unlock hidden pathways within the infinite series that lead to pi, achieving much faster convergence than many methods before.
It's inspiring to think about his contributions, especially considering he worked outside traditional academic circles. It really speaks to the universal nature of mathematical beauty and exploration. But I'm curious, with the advent of modern computers, how has our approach to calculating pi changed?
Computers have taken pi calculations to a whole new level. Using sophisticated algorithms like the Chodnovsky formula, we can now compute trillions of digits of pi.
Trillions. I have to ask, why do we need to calculate pi to so many digits? Is there any practical benefit to knowing it with such extreme precision?
You're right. For most practical applications, even a handful of decimal places is sufficient. But these massive computations serve a different purpose. They help us stress test computer hardware, develop and refine algorithms, and push the boundaries of what's computationally possible.
So it's not just about the digits themselves, but also about what we learn about computational techniques along the way.
Exactly. It's a testament to how the pursuit of pi continues to drive innovation even in the digital age.
That's fascinating. But let's zoom out a bit. We've talked about pi in terms of circles and geometry, but I have a feeling it goes way beyond that, right?
You are absolutely right. Pi's influence extends far beyond its geometrical origins. It pops up in unexpected places like probability and statistics, where it plays a key role in the normal distribution, that famous bell curve that describes so many natural phenomena.
So pi helps us understand the patterns of randomness as well.
Indeed, but the rabbit hole goes even deeper. Pi shows up in quantum mechanics, signal processing, even music. Its presence in such diverse fields points to a deeper interconnectedness within the fabric of the universe itself.
Wait, music. Now that's unexpected. What does this all mean? Why should we care about this one seemingly abstract number?
Pi isn't just a number, it's a fundamental constant that helps us describe and understand the world around us. Its presence in so many seemingly unrelated fields suggests a deep underlying unity in the laws of nature.
That's a pretty profound thought. It makes you wonder what other secrets this ancient constant might hold.
And that's the beauty of pi. Even after thousands of years of study, it continues to fascinate, inspire, and challenge us, revealing hidden connections and pushing the boundaries of mathematical understanding.
Well, I think we've got a pretty good wrap unpacking this incredible number today. From ancient estimations to infinite series and even a touch of quantum mechanics, our deep dive into pi has shown just how extraordinary it truly is. And as we wrap up, here's a thought to leave you with. If pi is indeed infinite and non-repeating, does it contain every possible sequence of digits? Could the entirety of human knowledge encoded digitally be found somewhere within pi's infinite expanse? Something to ponder until our next mathematical adventure.